Hello, this is Hemant. So now I am going to take class on CATIA kinematics. So kinematics means giving motion to our product or links of our product or assembly parts. So this is called kinematics. So next, so what is kinematics? So digital mock-up, DMU kinematics. So in CATIA we are taking this tool in digital mock-up. Okay, workbench available in CATIA allows user to create simulation of assemblies. Simulation in the sense to giving motions to our product links or joints. So basically kinematics is a simulation showing where all of our parts in an assembly are in time as it goes through a cycle. This technology is useful for simulating steady state motion. Steady state means with no acceleration, as well as in evaluating motions for interference purposes. So next I have some examples for this. So our first example is Revolute joint. So what is Revolute joint means? A Revolute joint, also called a pin joint or hinge joint, is an 1 degree of freedom kinematic pair used frequently in mechanisms and machines. The joint constrains the motion of two bodies to pure rotation along a common axis. The joint does not allow any translation or sliding linear motion. The contact between the inner and outer cylindrical surfaces is usually assumed to frictionless. So this is the contact between inner and outer circular part. Okay. So this is the common axis. Next, where it has to be used. Examples of Revolute joint: wheels or rollers, chains or swing bridges using multiple Revolute joints, rotating doors, catapults, levers. So in these type of joints we are using Revolute joint. So now I'll show you how the Revolute joint can work. So in our modeling, so I'll show this motion in CATIA. See, now here we have CATIA kinematics. Okay, so this is the part I have created. So now where we get DMU kinematics? So here in start we have mechanical digital mock-up. So here we have DMU kinematics. When you switch it on, click it on this DMU kinematics, you get this kinematic joints, DMU kinematics tools. Okay, so this is the basic tool, DMU kinematics. Here we have joint section. So just take it out. So here we have 16 type of joints. So now we will see one by one. So in this, our first one is Revolute joint. See, this is Revolute joint. So first basically we have to fix the part. So I'll just take this fixed part command and I'll name new mechanism as Revolute. Revolute, can name anything. I'll just say OK and I'll select the part which has to be fixed. So next I'll click it on this command Revolute joint. So now this window has opened. So it is asking line 1, line 2, plane 1, plane 2. Okay, so I'll just take the center axis of this part and this hole. So this is I'll take C part 1, part 2. Next plane 1, plane 2. So I'll just take these two planes, contacting planes. So next, if you have any distance between these two planes, you can select offset. Otherwise, you don't want to select. So I'll just enter command. So this is the angle driven command. So which is most important. You should take any one command for one joint. I'll just take this angle driven and say OK. So now it is mechanism can be simulated. You can simulate, means you can see the motion of our part. Say OK. Now have my simulation with commands. So just click it on. Okay, here I have one more tool, that is DMU generic animation. So here I have simulation command. I just click it on here, select the joint, say OK. So here kinematic simulation Revolute. So this is the Revolute joint. So first cycle I'll just move it, so 360-degree rotation. So if you want, you can click it on here. In this box you will get lowest value. We have 360 minus 360. I'll make it as 0. So you can, I'll spin box increments means first cycle have to calculate it first. So I'll take 20 instance. So it is coming to 0 to 360. So now I'll move it by clicking here, or you can drag this line. Okay, so I'll just move it and make a one cycle calculation, and I'll just edit simulation. In this edit simulation dialog box, I'll make it insert. See here it is cycle, one cycle is inserted. So now I'll just minimize the speed. You can control the speed of our part. So next you can change the loop. So if you want to make it move by continuously or single time or repeated times, you can change the loop here. Now I'll just play it. See, the speed is more. I'll just go here and make it slow. So this is how your Revolute work. So wherever you get the rotatory parts, you have to give Revolute joint. So this is the Revolute joint. Okay. So if you want, you can save the part. Just keep Ctrl S. So our next joint is, next example is prismatic joint. So Revolute means it's a rotating joint. So prismatic, in the sense, it's a linear movement joint. As in picture shows, it's a linear movement joint. So this is also 1 degree of freedom. Works on 1 degree of freedom. So a prismatic joint provides a linear sliding movement between two bodies and is often called a slider, as in the slider crank linkage. So you all know about the slider crank mechanism. So this is works on this slider crank mechanism principle. So a prismatic pair is also called a sliding pair. The relative position of two bodies connected by a prismatic joint is defined by the amount of linear side of one relative to another one. This one parameter moment identifies. So this is the major parameter. Based on this parameter, we call it as 1 degree of freedom kinematic pair. So where it has to be used means hydraulic and pneumatic cylinders. So movement of hydraulic or pneumatic cylinders, so this mechanism can be used. Okay, so next I'll show it in CATIA tool. Here I have created a part for prismatic movement. So our next topic is prismatic joint. So for this, first I have to fix the base part. So I'll just take this base part and name it new mechanism. Name it as prismatic. Name it as prismatic and select the part. So this is my fixed part. Now I'll just click it on prismatic joint. So it is asking for again line 1, line 2, plane 1, plane 2. Line 1 means, so I'll select this edge and this part edge I can't find, right? So for that I'll make sure hide any one of this part. So I'll hide this part and I'll select this line. Next I'll select here only plane 1. The added parts will be get here, swap visible space. Swap visible space, I'll select here and I make a plane. I'll select command as length driven because it's a linear movement part, so I'll select the length driven command. So I'll just say OK. So the mechanism can be simulated. It is eligible. So now I'll make this part to be shown. So right click and make an hide or show. Again I'll go and click it on swap visible space. So now part will be visible in the working space. So next in DME generic animation, I'll click it on simulation command, Prismatic will select, so OK. So it is a -100 to +100, so it is going out of the box. So I'll make it -60 to +60, and I'll take instance 20. So now I'll make a move for this part. So I'll take this one cycle and insert. Now take repeated movement. Just minimize the speed and say OK. Play from start. So this is how linear prismatic movement can work. Okay. So this is the basics of these two joints. Okay, thank you. In the next class I will show you the next joints. In the next video we will get